Hello students, in this video let's start studying about reactivity series of metals, that is a part of your chapter metals and non-metals, and about displacement reaction. What is reactivity series? Reactivity series, it is nothing but it is a series of metals that are arranged in the decreasing order of reactivity. That means in reactivity series we have all the metals. There is except one, which is the hydrogen, which is a non-metal, but we have included hydrogen in the reactivity series of metals because hydrogen also forms positive ions just like metals. So that is why we have included hydrogen also in the reactivity series. So in the reactivity series where the metals are arranged in the decreasing order of metal, which is on the top or the topmost metal in the reactivity series is the most reactive metal, and the metal which will lie in the bottommost part of the reactivity series, that is the least reactive metal. So that means the metals, they are arranged in the decreasing order of reactivity. So when the metals, they are arranged in the decreasing order of reactivity, that is called the reactivity series. Let us now see the reactivity series. To start with the reactivity series, this is a learning trick which you should remember to learn the reactivity series, that is P, S, C, mesotyl. This, if you will remember, you can write down the reactivity series. These are the first letters of the metals which are present in the reactivity series, where first letter is P. P stands for potassium. So potassium is the metal which lies on the top of the reactivity series. Then K stands for potassium. S in the PSC mesotyl stands for sodium. Symbol is Na. Na is sodium. So after potassium, sodium. Then C stands for calcium. Ca. Next M in the mesotyl stands for magnesium. A in the mesotyl stands for, yes, you are right, it is aluminium. Z stands for Zn, that is zinc. I stands for iron. Symbol is Fe, which is the Latin word derived from the Latin word ferrous. T stands for tin, that is Sn. And L stands for Pb, that is lead. So over here P, S, C, mesotyl. So the reactivity series is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. After lead in the reactivity series, hydrogen, which I told you that this is a non-metal which is included in the reactivity series because it also forms positive ions just like the other metals. Then there are 5 metals. I can say these are the metals which are very less reactive and we can call these metals as the magical metals because they do not react like the other metals which lie above hydrogen. These are copper, that is Cu. Cu stands for copper, which is derived from the Latin word cuperus. Then Hg stands for mercury, symbol for mercury. Then Ag, that is silver. Au, that is gold. And the last one is Pt, that is platinum. So this is the reactivity series of the metals, in which all the metals, they are arranged in which order I discussed with you. The order of the reactivity series, it is the decreasing order. So the metals, they are arranged in the decreasing order of reactivity. That means potassium, which lies in the top of the reactivity series, it is the most reactive metal. And platinum, which is Pt, which lies in the bottommost of the reactivity series, this is least reactive metal. So most reactive is potassium, least reactive is platinum. To study the application of this reactivity series, we will study the displacement reaction. But before that, we need to understand that the metals which lie on the top of the reactivity series, they are more reactive than the metals which lie below in the reactivity series, like calcium and iron. Then since calcium lies above iron, so that means calcium is more reactive than the iron. Now if I consider another example of, let's say, aluminium and copper, then since aluminium lies above copper, this means that aluminium, it is more reactive than copper, and copper is less reactive than aluminium. So we have to check the position of the metals in the reactivity series. The metal which lies above in the reactivity series, it is more reactive than the metal which lies below in the reactivity series. Displacement reactions are a part of the application of the reactivity series where it is used. What are displacement reaction? You have done it in the 7th standard also, that the reaction in which a more reactive element displaces a less reactive element from its salt solution. That reaction is called the displacement reaction. What happens in general, we can write it down, that if there is an element A and there is a salt solution XY, let's say XY is the salt solution, that means a solution which is prepared in water, then if A, it is more reactive than X, let's say A element, it is more reactive than the X element, then it will kick off the X from the salt solution and now it will form AY plus X. That means A has displaced X from the salt and it has formed a new salt AY, and X is removed from the salt solution. Let us take the example over here. If I take that I have iron nails and put it in the copper sulfate solution, the color of copper sulfate solution is blue. Iron nails, when you put it after some time, since in the reactivity series we know that iron, it lies above than copper in the reactivity series, so iron is more reactive than the copper. So a powerful element iron, which is more in reactivity or higher reactive than the copper, then it will displace the copper from the solution and it will form a new salt FeSO4 plus a brown colored copper powder is removed. The color of the solution now, it will change into green because the color of iron sulfate is green. So the solution will change after the reaction from blue to green, plus a brown powdery substance will be formed that will be of copper. So this is an example of displacement reaction. There is another activity which is given in your book. As you can see in the picture, they have used the magnesium ribbon and they have put it in the copper sulfate solution. You can see in the picture the color of copper sulfate is blue, as we have discussed just now. So the magnesium ribbon, we will dip it in the copper sulfate solution. Now again, if we look back into the reactivity series, we know magnesium is more reactive than the copper as it lies above than copper in the reactivity series. So it will be able to displace the copper. It will kick off the copper from copper sulfate and it will form magnesium sulfate. As you can clearly see in the picture, the color of magnesium sulfate in the second beaker they have shown, it is colorless. So that means the color of the solution now, it will be changed from blue to colorless. Earlier in case of iron, it was changed from blue to green. In case of magnesium, the color of the solution will change from blue to colorless magnesium sulfate. Again, a brown powdery substance of copper is formed. So this is again an example for displacement reaction. That is all about the reactivity series and displacement reaction. We will be studying about the noble metals in the next video.